Okay, I think we're about ready to get going here. If there's anybody lingering in the doorway, if they could just come in and have a seat, we'll get started. We're all set over there? Yeah? Okay. Welcome, everyone, to this session, which is the future. No, sorry, wrong one. Automated data quality at enterprise scale. And the session is sponsored by Initio, as you can see from the big sign here. And we have two speakers from Initio who are going to tell you all about it. They are Kristian Desch and Ed Sheehy. I almost said Eddie, but of course, if you're from the neighborhood, I would have called you Eddie. Kristian is a global IT executive and consultant with over 25 years of experience delivering and operating transformational technology and data-driven analytical solutions. Before joining Initio, Kristian spent 15 years at TransUnion, delivering complex credit risk software engineering solutions. Kristian also spent over 13 years as a consultant at Accenture, focusing on financial services technology-based solutions. Ed Sheehy is a strategic consultant with Initio Software, where he provides customers pragmatic advice based on decades of experience in retail, commercial, and investment banking. Ed has worked as a bank officer at JP Morgan and as a management consultant with PwC's banking practice. Ed helps customers envision the art of the possible with Initio Software and works with them to improve the business case via a technical proof of concept. Ed also advises on project execution and operations designed to deliver on business case for change. So our speakers have requested that they take questions as we go along, but I want you to know that if you ask a question, the people online can't hear you. So either you wait for me to bring you a microphone or they will repeat your question.
I'm happy to repeat them, yeah. But we'd like this to be interactive just so you're not just watching.
So with that, I'm handing it over to our two speakers and give
Thanks,
them
Carl.
a warm welcome. Thanks.
All right. Again, my name is Kristian Desch with Initio. Ed and I are here to talk today about things we've seen in the field with our customers around data quality, some observations, and how we think there's a better way to do this and are doing it to really scale at the way you need to.
And although we have the logo on the side here, this is not meant to be an infomercial. So
Correct.
This is really like practices that we think are generally applicable, but we're sharing from our experience.
All right. We all know data quality can be very challenging. That's why you're here, hopefully to get some insights on how we can make it better together and share some learnings. You know, as we know, part of the challenge is we are all dealing with hundreds of systems. Those systems have potentially thousands of business concepts and terms. And then when you really look at how do things get instantiated in the wild, it can turn into millions of technical elements. And how do I keep this concept of what is good when I have to map that to millions of things? And that's really kind of the core challenge around how do you keep your data in a position it needs to be when there's such a scale out of elements to manage and control.
Yeah, one little factoid there is like one of our banking customers is one of the top 5 banks in the United States. We have done extensive data lineage for them, and we can see that they have over 100,000 point-to-point interfaces across their systems and processes. So this is the type of scale of problem that we're talking about.
Yeah. And it's not getting any easier. Our customers, the business demands even better data requiring even finer grained controls. It's not going to get easier. Hyper-personalization, manufacturing processes, dynamic pricing, dynamic supply chains, increased regulatory burden. Obviously, that's been going on a lot in financial services, but there's other industries realizing that they're being regulated and need to demonstrate controls and provenance of their data to support these increased regulatory burden. So what's been going on? What are some of the approaches we see out there, and what are some of the challenges with them? We kind of have this whack-a-mole problem where you find an issue, you fix it, you're frustrated about it, and then you just keep whacking away. You report a fix, it may be addressed or not, and it's this kind of back and forth, hence why we call it whack-a-mole.
Yeah, so this approach has its good and bad points. So first of all, you're responsive to different business stakeholders as they have issues and you're trying to fix their issues. Typically, you're fixing them at the point of data consumption, okay? And you're not fixing root causes of this, not to get all Six Sigma on you, but you're not fixing the problem at its root cause, and so the problem is probably pervaded across your enterprise by just fixing it at the report or the feature engineering level for machine learning or whatever your customer experience design is. So what we're thinking is that you really have to solve data problems at the source, and that means holding the process and system owners, who are the producers of data, accountable for data. And what we're going to share with you today is some of our thoughts on how to get that done, because if I'm owning something like loan origination in a bank, and all of a sudden you're asking me to also manage data quality, it's like that was never part of my job description. It is now, but it's like outside of my realm. And if I have any street smarts, I will try and dodge accountability. So this is culture change.
And finding those tools and capabilities to remove the obstacles to allow the owner who's accountable to, in a sense, remove those barriers, in some cases excuses, for not being able to truly own it.
All right, so one of the problems is holding people accountable for opaque control logic that they can't understand. Many people implement data quality controls in SQL, and this is a trivial, not even really that complex a requirement, which creates a couple of paragraphs of SQL. And I'm again, this guy responsible for auto loan origination, and you're saying, Ed, here's a problem, and I'm going, or even like you pull me over, the Stadies pull me over in Massachusetts. What do you mean? I was going 85 miles an hour. How do you prove that? So you can't give me like some measurement or thing like this out of a process that I can't understand. So what we've found, and I really owe the insight to this to a woman I worked with at Wells Fargo many years ago, and she said, the business of culture change is taking away excuses for change. Okay, so firstly, the control logic has to be transparent. It has to be simple for people to understand how they're measured and being held accountable. And then it has to be consistent, because if the control logic is different at the point of consumption than it is if I try to also put that control far forward, that's problematic. So you can't hold people consistent. And complicating the situation, because I realize we're talking to people across many different industries and government agencies and things like this, is how do I get consistency of data quality control when I'm using multiple different technologies? Okay, so this is also problematic. How do I really effectively write the control once and reuse it many times?
And how can you be accountable or own the control if you're trusting some other party or group to implement it for you?
Yeah.
There's a disconnect there. The trust may not be there. Yeah, I own it, but these guys over here better have implemented whatever requirement.
And again, not this in SQL. I was a DBA, and I have to confess, in prior lives, and so there's a lot you can do with SQL. But in this particular case, it's maybe a way of reacting in the whack-a-mole problem and responding, but it is not going to drive culture change.
There's also, centralized things can be good. There's one team with the expertise, but to implement things, to implement standards, to do it in a consistent way. But there's the scale problem. How can you, how do you get the line of business knowledge? There's a translation issue here.
Yeah. So amongst the problems that we find, particularly when people are deploying control logic in the cloud infrastructure, is guess what? All the data isn't on the cloud yet. And maybe it never all will be, right?
Yep.
Even Jamie Dimon recently kind of clawed back a statement about cloud first and saying, well, cloud is just part of our something, you know. So the reality is that if you want to bring the control to the data rather than data to the control, and when you're bringing the data to the control, you also have this ETL problem of translating the data in context, which might have been, shudder to think about it, IMS processing in COBOL written 58 years ago. And if I have to unpack that IMS and then translate that into an API payload, that's an ETL job. That's a data transformation job. So I'm not able to scale up programs like that in which I have to have people transform the data to meet the payload of the central control. Also, there's a famous quote from Ronald Reagan in which he said, the most frightening thing in the English language is to say, I'm from the federal government and I'm here to help, right? So when you or the contrary of that is like, I'm from the head office and I'm here to help, right? And so people in lines of business naturally freeze up because that's bureaucracy, it slows things down, and what we really need is distributed but coordinated central controls, a controls catalog that people can reuse. There's also another function here in this central control model that we're seeing is a lot of people generate from these controls, particularly if they're machine learning type of controls, or any type of like machine learning or expert system like this, will generate an inordinate amount of false positives in any business that has multidimensional data of any complexity. So people who are stakeholders, who are whatever your organization is, you have too few subject matter experts, right? And you will burn them out if you start routing them data quality issues that are false positive after false positive after false positive. It's very easy for them to disengage and say, I've got a day job. I don't have the time or bandwidth for this anymore. Come back to me when you're serious. So I'm not saying that machine learning and anomaly detection is a problem. I'm saying you just have to be aware of what you're doing. And that's really our next slide, right? So and again, what we've seen across our customer base is that the machine learning techniques are very good for identifying what are the grosser, simpler, technical data quality issues. But if I have any complexity in the business logic, it generates a lot of false positives when it's a trade-off between a quirk in the business. It just happens to be that little outlier there is a high.
Turns out it's good.
Yeah, that's an auto loan for $10 million because it's some rocket-powered Tesla that we insured. So it's possible, and again, you exhaust your stakeholders, and also the machine learning approaches tend to also replicate the whack-a-mole situation. So machine learning finds an anomaly in this business process. The same data condition may be in another business process, but it wasn't an anomaly at that point, and you maybe needed control at that point, and you need that control to be consistent. So if it can implement variations of control logic because it's an expert, data-driven expert system that are not consistent and also not always transparent to the business. Oh, the robot said I was driving 85 miles an hour. That doesn't help either. So again, think about data quality programs as driving culture change for the accountability to change the business systems and processes that are the producers of data, and how to be their friend, how to give them help in this mission.
And I don't think we're saying it's bad. It's just another tool, and you got to understand kind of the layers of controls you have, and various backstops in your data quality. So we're not trying to say anomaly detection is bad. It's one of many tools. And like anything, there's trade-offs with this approach.
And you know, there's no silver bullets
Yep.
here. This is a
People and data are messy.
it's messy, and organizations are complex, and we're dealing with systems and processes that are I used to work at MetLife. There were systems written in Met English, predecessor to COBOL, that Grace Hopper created in 1948. So debugging situations and processes like that is not easy.
Any questions so far? All right.
Are we making sense?
Yeah.
There's always that risk. Okay, so now we're going to talk about some of the lessons that we would like to share about things that work, things that we find to be pragmatic and effective. All right. So the first is this is a statistical observation that you've got far more physical data than you have business terms and concepts, and so the business accountability for business people is at the business term level. It's on concepts, like net asset value, which is tied to a business glossary. Okay, it is not field P47. Okay, because business people don't know what P47 is, and one of the things that we've found is using machine learning techniques assists, and amongst a couple of other methods that we've come up with, for taking physical data and mapping it to semantic content, okay, in your business glossary. And that's a whole other talk into how we do this, and we're happy to have that conversation with you. But the reality is that that having people understand in business concepts what they're being measured for, being able to deploy controls that are transparent in these business terms is really critical to driving accountability.
And we're happy to talk to you in more specifics on how Initio handles this. But this is really powerful stuff. If I can figure out in my technical soup what it means at the business term level, and then I can think about my data quality rules and controls at the business term level, and the power of machine learning and other computer science techniques can take care of the rest from there because it's driven by good metadata. That's one technique on how you scale and get out of this mess of how do I get these concepts down to the technical level. What is the must use domain values for this field? I literally might have a requirement, depending on the system and the technology, to re-implement the same rule. There are ways to auto-generate and cascade those rules. This is one way out of the mess. Think about your controls and rules at the business term level, and there's technology and partners out there that can help automate the cascade down to the technical level. Really powerful stuff.
This woman in the back looks skeptical. Good. We like skeptical people.
Yeah. And one of the other things we see is because you can define controls at the business term level and your business concepts, that makes these controls easy to move. Maybe if I have a control at the tail end of thing, and then now I realize this is material, you can move the controls. They become fungible. I can get them closer to the system of record and maybe address or catch it farther up the stream because the controls aren't necessarily tied to a specific implementation anymore. And it really gives you the ability to adapt and move your controls as you learn things and shift your quality left upstream in your environments.
Yeah, now so if I was a prop comic, I'd now open my jacket and you'd see that I was wearing suspenders plus a belt. But what we're saying is you do need the belt and suspenders approach.
Yeah.
So the fact that you have a preventative control far forward in the process means that you probably still need a detective control at the end of the process. And there's also, by the way, horrible things happening in large companies with like, for example, I think, Dan, you mentioned this earlier this week, there was a data flow that you knew there was 47 hops from the source of record system into its end consumption point. So there's 46 interfaces here where data could have gone wrong. Maybe it was pristine at the source of record system, and it's some intermediate process that happens. So there's also the way to deploy these controls with a binary search technique. Where is the problem? Well, let me start at the end. Let me start at the beginning. Let me put it in the halfway point. At step 23. Oh, it's still good at step 23. Let me go back to step 46. In the middle of that, my arithmetic isn't as good as it used to be. Let's say step 35. We test and see where the data has gone wrong. So the ability to reuse controls like this helps localize where the problem originates. And you probably need the controls at every interface, but there's also the broken pipe problem. I don't know what's in the walls of these buildings. I don't really care. But when I have a leak, I really care. That's when I need data lineage. That's when I need to understand what to fix. As many of you probably know, creating data lineage is very expensive. And if you do it as a manual process, it's out of date as soon as you print it. Okay? So there's a need to keep on top of things where you have problems. And so fix the broken pipes when they leak. And this is a process for helping localize where you have broken pipes.
As a data quality professional, I'm trying to scale, and I can do it with enterprise business terms, like U.S. Social Security. The characteristics of that value should be the same from creation, where it's stored, to where it's persisted.
Right.
And that's great. And the problem I have with conventional data quality, when the data stewards are doing it's a CDE, I'm profiling the data here, and when it gets migrated through an API or someone decides to concatenate it or things like that, it's at different hubs detecting that it changed. Now it's concatenated. It's a different animal. It's no longer that same thing. It has different logic.
Yeah.
Can you repeat what she said for the online audience?
So actually, we'll get rid of Mike, maybe. Yeah. So you actually didn't have a question. You had a statement.
Well, no, I mean a question as to how fast can I scale this, and detect where, because to me the combination of your solution, what I've seen is the lineage view is really helpful in this. So how fast can I scale? Can I look at something, say apply?
So this is a bit of a side topic, and we can go into the more detail. So Ab Initio processes automatically generate lineage down to the field level, and we also show the calculation logic within an Ab Initio process. And are you with the Social Security Administration?
No.
Okay. Well, we work for the Social Security Administration, so I was just going to mention that. We'll fund all your retirements. No, that's a blanket promise. I have to claw back. Lawyers are just yelling in my ear. So we can, at high scale, do any type of what is known as statically analyzable code. So for a French bank, we process 18 million lines of COBOL to generate lineage out of that. We process other competitors, so-called competitors, logic, like Informatica, DataStage. We process Excel for lineage. We process SAS for lineage, the SAS ETL components. So different technologies that are statically analyzable. Technologies that are not statically analyzable is like assembler code, because assembler code can write other assembler code and configure it. So can C, so can Java. So things like that we can't promise, but then you need manual documentation to plug in the gaps in those areas.
But I think what we're saying is, lineage is a powerful canvas, and we use it to overlay other concepts like, where are the controls in my lineage?
Right.
And I think to address your comment, we know this because we're doing it, but there are ways to create controls that aren't hardwired to the specific field or the specific technical implementation. If you have a truly metadata-driven processing engine that can profile, that can run these checks, you can define these things. Yeah, you're right. A social security number is a social security number in this concept. Now, whether I represent it as a bit string or a character, there's ways. The machine can handle that for you. So you don't need humans to know, well, how do I implement your SSN control when it's binary data, EBCDIC data, ASCII data, numerics with dashes, without. there's a much better way that can be abstracted now, and you don't have to deal with the hard wiring problem anymore.
The other thing, this is just a general observation approach, is that successful programs execute both top-down. So you have, you're implementing controls based on policies, and every policy needs a control to enforce it. In New York City, there's a policy that you shouldn't jaywalk. It's not policed. I jaywalk all the time. I grew up playing stickball in the streets. So you need policies to enforce. You need controls to enforce policy. Okay, if you have data policies and they're not tied to effective controls, then you're just creating paper documents that don't drive change. And this has been what we saw in many first-generation CDOs, is they were very involved in exercises like documenting business terms, creating policies, but they weren't implementing the controls to enforce that definitions were enforced, or they weren't really looking at the reality of the data. We only have 2 genders. No, you actually have more. Okay, and so there's a need to understand and adapt to these circumstances. So top-down policies is a way of implementing controls, particularly for things that are most strategic. In fact, I would argue that any business process that you create needs to be controlled. Right? So what's the business of management? The business of management is to measure and control, to drive to a plan. So any process, top down, should have some controls around it. Any data requirement that you need to execute your strategies and your business processes, top down should have policies that indicate what is a controlled process, and then implement the controls top down to execute them. The controls to drive reuse need to be registered in a controls catalog. The controls catalog needs to be friendly and accessible. And a control that might work for Dan in one line of business might be usable by Cal, but he needs bits and pieces of the control he needs to modify. So he's creating a control, and he can edit the control. And there's also governance about who can create controls and edit them. But the major point here, without getting into too much of the weeds on this, is that controls need to be registered in a catalog for reuse to drive change. And that's a top-down. So policies driving controls registered in a catalog is a top-down initiative. At the same time, as we saw with the whack-a-mole problems, data is fine until we start using it. Okay, so people then need to respond to these situations, and where you have a response, you can implement controls that way too, bottom up at the report level, then implement them in a control. Maybe, to your question before, there's a lineage that we don't have. We know there's a problem at the break. We don't even necessarily know where the source of record system is, right, where this data is originating from yet. But at least put the detective control in place at your point of consumption, bottom up, and in lines of business do this. So individual lines of business and departments can create controls that are also registered. They can be registered as localized at this point. We're just doing this within our part of the business. But other parts of the business can see these controls exist, and maybe they can say, I can use this, or I can use this in whole or in part in my business as well. The other thing about driving change is, so again, transparent control logic, consistent control logic, and an accountability system. So Initio provides an accountability system, but we also integrate with things like Jira and ServiceNow with different customers. So, but when I'm giving Dan, just to pick a Dan at random as my
don't sit in the front row.
Yeah, don't sit in the front row. You should. But when Dan has a data quality issue that we detect because he's the process owner, and he can understand how he's being measured, and he can understand he's being measured consistently and therefore fairly. I have young grandchildren now, and I'm amazed how they'll fight over the fact that 2 of them are getting different size slices of cake, right? So fairness is really important to human nature. Consistency in measurement is also a way of creating fairness in the application of the control. That's not really enough always, because what we really need to do is drive directive action to respond to the situation. So there's a lot of context metadata that you know, the best systems provide to say, here was the incident control, here's your records with issues that fail the control, here's the profile of the records with issues. All of these were data entry errors by Sally. Maybe the problem is that Sally needs to spell, okay? Or they're a systematic problem with foreign exchange translation. Maybe our master data table for foreign exchange translation is wrong in this business process. And so the process of detecting things like this needs to provide directive metadata to people around the context of where the issue is, as much as you as professionals can provide to people. You, again, trying to think through with empathy and understanding. If it was my job, what would I need to do this? And collect the metadata out of sources of record systems so that people can solve problems like this. And really, what we're talking about here is a complete controls model that I was alluding to earlier. So, you know, I worked at Pricewaterhouse for a number of years, and I had audit issues beaten into me as a child. So you need policies to drive controls. The controls need to provide transparent and consistent metrics. The metrics need to drive action. That's what we're talking about, is giving directive action. And then there's overriding analysis on the control. Is the control effective and efficient? So there are, in life, controls that are not effective and efficient. And jaywalking in New York is an example of that. The police don't get any credit for coming to the station house with me for jaywalking on Park Avenue. It ties up New York City police officer time. It doesn't stop the problem. It's not efficient. A control that to implement costs you $10,000 a year, but only saves you against $1 of loss, doesn't make sense either. So you need to look post-implementation to audit the effectiveness and the efficiency of the controls. A control that creates data issues that don't that have adverse effects is also possible. And my favorite example of this was a bank in Malaysia that had put in place their money laundering logic. It's not a data quality issue per se, but the issues were routed to the individual bank officers responsible for the retail or the business relationship. And after a quarter of doing this, the head of loan origination said, loan originations have plummeted. Why have they plummeted? They've plummeted because all the bank officers are trying to resolve data defects and issues that came out of the money laundering issue. So, let's be humble. Any control or process or thing that we do may have unintended consequences. Post-implementation, audit the efficiency and effectiveness of this. And this is to go back to really controls theory, which comes out of like 50s and 60s, and people like Deming on total quality management. Next slide.
So another kind of key concept is if you're going to hold someone accountable, you have to kind of give them the tools they need in a view that they understand. So that's also, and try and remove the telephone effect here of, if you own something, you have to define the controls or data quality rules for it, yet how do I get the human and the telephone effect out of this? A lot of that is get the right user interface in front of the right user. And looking at ways to capture business concepts and logic and familiar, maybe spreadsheet-like interfaces or logical drop-downs is also a way to your control or data quality requirement. As you author it, it's now exists. So that's also a key concept is, get IT development or control spec creation out of the loop. If I can document the requirement, it now exists as a data quality control or measure.
And this kind of self-serviceability for people within line of business to implement detective controls where they have a spot problem in logical business terms has to be very simple and easy and intuitive to use. And if they have to go to the head office to ask for, file a ticket and get a response in 18 months, that doesn't work, right? So we're really seeing that to scale this needs this self-service capability. And we've discovered that one interface doesn't rule them all.
Yep.
Kind of parodying some movie title. So we have a simple query by example type of interface, if you're familiar with the history of computing interfaces. So it's just drop downs with this is what I want. It's context sensitive. You'll get the operators for dates when you're dealing with a business term that has dates associated with it. If you're associating different fields, it maintains this. And it can scale to a certain degree of complexity. But at another level of complexity, you get into things that are like truth tables, okay? So there's many different cases that you need to enumerate, and for this case, this is a data quality defect. For that case, it's a different thing. And again, for multidimensional data or complex data problems, you may need this kind of more Excel-like interface. But so you need multiple different tools for different parts of the course. It's hard to play golf with just one club.
Any questions on this?
Filtering logic is a lot what I deal with. Oh, sorry, me. Filtering logic. So basically when you work with the business, it's like you profile the data and you say, is it every single record, every single row? Or is it 5 other fields and then the target field?
Yes.
How easy is that to build?
So you just stimulated a recollection, which is to answer your question in a roundabout way. Another lesson learned, which didn't make it into the deck here, is that when you're getting business people to author controls logic, they miss things like this. So they don't necessarily filter it, and they talk about every record. And now you're monitoring in real time something that's happening like 600,000 transactions a second. Okay, yeah, lots of false positives, things like that, because your logic was too wide open. Okay, and so the other thing that we've discovered is, and this is problematic. Firstly, in the ideal world, you're developing the rules and you're testing them against production data. Okay, getting access to production data, not always feasible. Okay, so the answer to that is that these controls can be promoted in a provisional way. So we can do the digital twin stuff that the McKinsey guy was talking about in terms of taking data and from production data and masking it, subsetting it, so you can test efficiently, but still the real world is different than any laboratory, okay? And so when you promote a control, you can promote it on a provisional basis to say, and again, I'm using Dan as a stalking horse here. Dan, we're measuring you with this control now. It's on a provisional basis. For the next 30 days, you're shadow accountable for these results. And Dan looks at this and goes, I got 50,000 false positives out of this. It's not precise enough. What you need to do is put filtering logic in here, Ed, you idiot. And I will respond, and we'll adopt, but again on a provisional basis. And also, this is also behavioral conditioning for human beings. I didn't do so well with my children, but with my grandchildren, I'm learning. So I'm going to say, you can put your hand in the cookie jar for the next 30 days. After that, we're going to chop it off. Okay, so things like that have to happen. You just give people a little bit of leadway to understand that they're being governed in this way. And you can even generate, as some of our customers do, shadow reporting. So here's the data defects that you're held to as being accountable. Here's the data defects that are shadow accountable and the dates that they come into place. So it's human beings, people.
Yeah.
Yeah.
All right.
And I was joking about chopping children's hands off.
I think this is you.
Oh, this is me?
Yep.
All right, so this is kind of a review of everything we want you to take away from today's session, right? So business needs to specify data quality control logic in business terms. They need self-service interfaces to do this, okay? You need a data dictionary. You will need, as we mentioned, to fix things, you may need lineage. And technical lineage, but which was another topic that we didn't cover today, technical lineage is often looks like a circuit diagram. It's too complicated, so you need to aggregate data lineage up into business lineage. In one case, for example, an investment bank, there was 10,000 data elements and 50,000 steps, and we just had it as front office, middle office, back office. So you aggregate it up to the level of the business that people can understand. They don't need to know all the engineering details. Okay, so business needs to specify data quality controls in business terms. The business needs to specify control points along, as what I just mentioned, a business data lineage. Yep. They don't need to know all the details that go into technical data lineage. It needs to be aggregated up. There's no one view of the operation that works for everybody. So just like in relational databases, where you can have one physical instance of the data and different views of the data, you can do the same thing with lineage.
And Ed, I'd just add that really is a key capability. We see the ability to kind of dial up or dial down into your, there are parties that might want to look at the circuit board, but most people want to know what the major steps are, and that is possible. When you have semantic knowledge of what your terms and where they exist in the technical reality, these capabilities become very possible.
Yeah, and then completing the wheel here, and it's business that specifies whether the control is provisional, as we mentioned. Okay, so what's the word there? Business. So this is not IT doing this. This is IT giving the business the technology and data infrastructure to implement business control.
Support and implement the systems for others to operate.
So one of the ways that Initio does this is that we're both a metadata processing as well as a data processing engine. So we can take the metadata specification from those interfaces that we flashed before in business terms, and we can generate the control logic that is the specification for a technical implementation. So the specification for the technical implementation can then bind to the technical metadata for the record format. And if the record format is an IMS hierarchical structure, or it is a JSON document, or it's an XML document in a segment of an XML document that's coming through on RabbitMQ, any and all of those are physical implementation points. And so the key to what now I'm actually giving an Initio infomercial. The key of what we've discovered is this is a critical differentiating for Ab Initio, the fact that we can process any of these record formats. We don't process every type of data. We're looking for structured and semi-structured data. But that semi-structured data is also a wide world, like Excel is kind of a wide world. We process for the Department of Defense Acrobat PDF files, but that's because they're always 10 bytes down, 15 over is the invoice number, 40 bytes down, and 60 over is the amount field. That's regularly parsable. So regularly parsable, semi-structured data we can deal with. But again, any of these legacy data formats, as Kristian said, in EPSIDIC, packed decimal format, we've seen it all. We've been in business for 28 years. Okay, so we can process any of those things, and we can do from the metadata on the business terms and the business specification of the control logic, generate the implementation. Okay, so that's our magic sauce. Controls can then be promoted to production on a self-service fashion. Okay, so that's a capability for business tagging, and again, promoted on a provisional basis rather than a hard accountability basis, and then monitor. Get from your metadata system the effectiveness and the efficiency of the control first 30 days, particularly on a provisional control, and then you're now got a controls catalog. A controls catalog with reusable control logic will accelerate the program. As we said before, there's roughly 3 orders of magnitude more physical data than you have business terms. So these are highly reusable across that to scale. They're transparent, consistent. They drive accountability, and they create a degree of business agility because you're taking out of a central team, you're distributing the ability to execute to different people across the enterprise, top down, bottom up.
I think that's it, yes.
Now we're looking for applause.
Yeah. Any other questions, comments, thoughts? Are we crazy?
We have some online stuff going on.
Oh, great.
And I'm not going to read all this because it's too involved, but I'll try to summarize.
Sure.
Because there was a little side discussion going on here in relation to this question. What are industries considering for the future related to data quality besides traditional DQ dimensions? And then a comment is suggesting a shift towards machine learning based techniques.
Now, so in the machine learning techniques, what we've seen and to date, and we're integrating with machine learning. I'm doing a project right now, one of the major banks, on instructing on prompting engineering for large language models. So we're familiar with them. We're familiar with their strengths and their weaknesses, and there's no magic here. So anomaly detection, as we mentioned before, is something that, with clustering algorithms or associative algorithms and neural nets, I could pretty quickly find out that I have an anomaly. But is the anomaly an outlier? Is it a quirk of the business? So there's limitations to it. It's part of the toolkit, but it's
an
not,
important layer.
But it's not. And maybe it's even necessary, but it's not sufficient. And also, again, for driving accountability, whatever you do needs a deterministic layer that the business can understand exactly what this means.
I don't think they were suggesting that it takes over. It's just another
No,
tool in the kit.
It's a tool in the kit, exactly. So then we agree. We agree. And any differences? Gentleman here with the beard? Yeah. No. You may not be the only gentleman with a beard, but you're the one I was looking at. Yeah. Yeah.
So not on that. I do have a question. So I don't disagree with at all with the logical business term sort of driving. I would say it a little bit differently. I treat it as, from a metadata perspective, that the business rule associated with the business term defines the standard of the control.
It's,
right. But with that, I want to get your perspectives on in a warehousing environment where you have a normalized conform layer and you're supporting multiple downstream use cases, right? How do you guys typically apply that? Because you have, you're using the same data to answer lots of different questions and lots of different perspectives. And I don't think I suspect that it's not practical to try to codify all of those expectations into rules that you're running against that control point.
Yeah.
Right? And so what does that look like?
So it's a little bit of the same question that the woman before, in terms of, I didn't get your name. That Ellen asked before. It's in filtering conditions. So, and again, it's this provisional promotion of a control and it being in production and people finding out that my definition of, I'm sorry, I'm a banker, so my definition of defaulted loan in Japan is different than it is in the United States, and you have it in a central warehouse and you're saying we've all violated this when it's fine for me, it's not good for the rest of the corporation. So that happens, and so we need the rule to be fine-grained, even though it's centralized data. So the rule condition would say this only applies to this business unit in this context with this business definition. And again, your business glossary should be able to define a defaulted loan at the enterprise level, at which you have to report to banking, but you have to report to your regulator as the head office. But there's local definitions that can be substantially different than the enterprise definition. And so the rule needs to be particular to the user that you're reporting. And so Ellen gets a pass because it didn't affect her, but you're in Japan, and so it does affect you. And that's what you need to do with centralized data like that.
And I'd also add not being brittle, being flexible, the ability to iterate. Oh yeah, I guess that was a bad idea, and then being able to change things without waiting for major release cycles, having an agile platform on top of all of that takes some of that fear out, because if you get it wrong, it's going to take 6 months for me to fix it is another challenge. And so having that agility to iterate until things are right, and you're never done because things are always changing, I think is another key way to
and nothing drives feedback in terms of fine-tuning these rules, like
assigning issues to the owner.
And particularly if your compensation is somehow now tied to data quality, when it was just loan originations beforehand or something. So again, a provisional program, and even when things are in production, they're not necessarily perfect. Even after the provisional period, you only notice this at quarter end or something like that. So there has to be a little bit of grace and forgiveness again, dealing with human beings. So the systems have to be adaptable and agile to deal with the complexities of business organization.
Very insightful. Thanks, guys.
I think there's a question here.
Thank you. It's a follow-up on the machine learning part, but also relates a little bit to the specification of the data quality controls, because of course, like, people need to specify the controls, but how do you plan to integrate with, on the one hand, input by machine learning models, for example, like outlier detection, and on the other hand, the input of the metadata? So
Well,
the
I'd say-
indirection
Yeah, so I think there's a couple things there. So, machine learning driven anomaly detection is very valuable, has a place, but that's typically not how, that's I want to say catch-all, but it's one layer where I'm not sure what's going to happen. Let's the machine come up with some recommendations or observations, and then maybe we'll keep them as is. And to Ed's earlier point, that can be a unique subject matter expert challenge. So you need that, and need to understand it's a different view onto things. But also, we see better scale instead of trying to scale out at applying lots of anomaly detection only at the very low level technical area. What are your key business controls? And if I could, those are the gnarly, nasty things sometimes. And then how can you cascade and auto-generate those into the technical is a way we've seen to get faster, better coverage. But again, not trying to discount. I've seen, cool systems catch things I never thought were, it has a place. And it's really a combination of the both.
Yeah. Also, you know that you're talking to a subject matter expert when he or she says to you, "I don't know why they say I'm a subject matter expert, but they always come to me with these reconciliation problems." Yeah. Okay. So that's the definition of a subject matter expert, and they have the wisdom to know that they don't know everything. Yeah. Okay. And so a subject matter expert who gets assigned an issue to try and find its things out, let's give them the tools to help them. Let's give them the data profile. Let's say here's the histogram of the data distribution in this database. Here's what the averages, means, things like that. Here is a machine learning insight into what we see as the association of this record with other records and clustering analysis and other methods. So they're all part of the kit to help a subject matter expert understand, again, supporting metadata as they're creating controls or as they're diagnosing and responding to controls. And I think, again, that this is, machine learning has a place to play here, but it's not going to solve the problems of driving business change by itself.
Said even another way, also applying it towards that semantic mapping to understand your business concepts. Where do they exist in your technical mess? We've seen a higher lift than just traditional, I would say anomaly detection, which is a broad
and to raise a topic that's not on the agenda. And I was talking to Dan about this as well. Dan,
Poor Dan.
I think you're sitting in the second row. So for data, and also a McKinsey partner kind of alluded to this the other day when he was giving his keynote speech. Data products need to be created by subject matter experts in the business, okay? IT can do the job of populating the raw zone, the technically sanitized zone of content, even conforming certain amount of data together, noticing the patterns of how people are using data. But to create final consumption data products requires business self-service ability to get access to the data. They need to know the data, the content of the data. They're going to see the data in logical business terms. They're going to need to understand. So the sine qua non of creating business. Oh, another Latin phrase there. The sine qua non of creating data products is to have business visible in business terms. And the machine learning techniques and other techniques that we use for doing this, I kind of brushed past this relatively quickly. It's really, and now to quote Malcolm X, it's by any means necessary. Okay, so we need to pull in data dictionaries. We need to validate those data dictionaries that were written in 1952 against the actual contents of the data. We need to pull in Irwin diagrams that might have this. We need to pull in COBOL copybooks that we're defining what the business terms are. For an insurance company in Hartford, we're actually taking metadata out of Telon, which is a mainframe code generation system, and we get the labels that people entered at report entry, and we pull that as metadata to match that to physical data. So again, machine learning is part of the story, but there's many different techniques, and all of these need to be used to give business meaning to data, because it's business people who need to be held accountable for quality.
A question over here.
Who need to create data products.
So it's not really a question, but just chiming into this, I'm Mona Rakibe. I'm a co-founder of a data observability company, and all we do is learn machine learning models that work for data quality specifically. So I'll chime in here on that context. Machine learning models work phenomenally well when you want to accelerate certain things. Specifically, he touched about anomaly detection, value outliers, time series drift, that you are historically seeing certain level of data. It's humanly impossible to figure out how the data is drifting over time, right? With the stewardship that we were used to, those type of approaches don't scale today, right? The human eyeballing. That's where you would apply models.
Yeah, couldn't agree more. And this is ties us in with another question.
Second point here, though.
Yeah, the second point I want to
Sorry,
make is they fail when there is correlation, right? Like if you are in US and fail, or at least there's a lot more research that needs to be done how to do it. And that's why we piggyback on the rules-based approach, where it's more tied to the business. And there is that sweet ground of combining these two, relying more on models, less on rules, because rules just don't scale. We're talking about petabyte scale of data, changing with different varieties, semi-structured data, Parquet formats. Every day somebody is announcing something new. How do you scale this? It's impossible. So there's that sweet ground. And then there's a third dimension, which is how do you take the output of these ML models controls and push it into remediation workflows and drive orchestration and automate all of this stuff. So that together is the beautiful story of ML plus control.
And I just want to echo one of the points that's also related to a question that was raised earlier about the dimensionality of data quality and stuff like this. So the reality is human beings, really only think about 3 or 4 dimensions in conceptual space. They get lost in this. Machine learning techniques can deal with much higher dimensional space where we would find the inconsistency and anomalies. So it is, again, part of the mission, but the fundamental mission, we think, is to drive business accountability, to fix things at the root cause with transparency and consistency. How are we doing for time?
We have 1 minute.
All right.
All right. Any last question? Yeah. All right. Thank you very much for your time.
Come
and
see
your
us at the
questions.
booth. Thank you.